Okay, this is a little video on the Tangle at scale. Obviously this is discussing clustering, and I'll step into the camera, clustering and what happens when you have the size of the overall graph and data structure getting larger than the network capacity of the nodes who are participating individually. So let's define real quick what I mean. I'm going to use the term cluster. Used it here and here. Forgive me, I'm not that adept at mathematical terminology, but the cluster is the past cones and future cones of I'll use for all of all identities adjacent in I guess a virtual identity graph. Not really a good way to word it, I suppose. But all transactions at some up to some depth, I'll say J, in a set of transactions of, I don't know, whatever identity plus or minus J. That's a really, this isn't like even good math or anything. I'm just trying to get the idea across. But a cluster is, in this case, these black transactions are markers of the cluster, and the cluster is these red and green areas. So the propagation rule the propagation rule that we take as a node when we're operating at a network capacity level, a network saturation level, the rule is generally just propagate always. If I receive a transaction, I intend to propagate it, and request from the cluster. So request from these red and green zones of interest to me as a person who runs that node. And then when transactions come, and my priority as in my network is to answer their requests first. And when I answer a request, I also send a request with it. I'll get to that in a moment. And I only store the cones of my cluster at my node. So I'm not going to store anything else. As far as the general Tangle is concerned, there's going to be some other things that I store that are data I'm interested in, that are outside the context of a cluster from that perspective. But I would say there's multi-dimension. There's many dimensions of clusters that are significant to any particular node. So this part deals with the storing of a cluster. Deals with when I am participating in it as a node. I have limited storage capacity, and I have limited interest really in long-term storage. I'm only interested mainly in storing what matters to me, not what matters to everyone. Maybe I save some outside of what matters to me so that I can provide service to other people if that has some economic advantage for me as a member in my local cluster. But there's an advantage that can be had to nodes that do not have much, if any, storage capacity, and this allows them to make determinations and pick sites on the Tangle without storing much of any of the Tangle. and it's this request mechanism. I think that I've covered before that in the IOTA network there is only one type of message that goes anywhere. It's a transaction and a request, and it's always one transaction and one request. But what the content of the request will be can make different behaviors happen. So if I propagate transaction I and I request the hash of transaction J, that means I want them to tell me J. I want to receive transaction J. And what the context of this is, I have received some transaction, it could be transaction I, and in its trunk or branch is the hash of transaction J. So I want to move down the past cone of that subtangle. If I have transaction I and I request the hash of transaction I, that indicates to my neighbors that I want to receive a transaction that references transaction I, that I want to move up the tangle. So nodes who have in their limited memory transaction, we'll say transaction K, which references transaction I, and they might have in their propagation stack, they might have a short list of transactions that might include transaction K to reference transaction I, and they could answer back even without a long-term storage about this. And this is how many nodes with very limited resources can participate in the Tangle in a way that looks a lot like simple payment verification of Bitcoin, with some differences. So we have I'm referencing these notions of a future and past cone. If I'm looking at a very large tangle where there's transactions all over the place, and I pick markers out of that tangle, these markers are represented by signatures that sign the actual transaction to the trunk. Specifically, in this case, it is the trunk transaction that they sign. It would be identical in form to the coordinator's milestones. It would be issued by any participant, and every participant who wishes to essentially stake their mark in the Tangle as similar to a vote. They are indicating to their neighbors what part of the Tangle they are operating in, and it gives their neighbors an indication of where to walk to if they want to participate with that person who issued that transaction. So we could have many transactions here which come from different participants. It could be your local Domino's, the taxi, the grocer, and the dentist. This is just a random example, but we see that I don't remember which one this was. A taxi. We see that the in the future light cone of the taxi is the dentist, but the grocer is the grocer is not it is not in the past cone of the grocer, nor is it in the future cone of the grocer. They're parallel to each other. And similar, we have Domino's is neither in the past cone of the taxi nor the future cone of nor is it in the future cone of the Domino's. I can't remember. I may have just made a mistake when I was saying there, but notice that these three are separate, but they do share some past cones. And then someone finding their way in a past cone who chooses an initial starting point from here, they would walk to this one or this one or this one, and this is presuming this is what is stored by a participant. They're going to have an opportunity to walk to one of these three, and it's going to be more likely to go to this one because we presume that each of these black dots are for a given node. Actors' identities of interest, because there could be any number of these identities in here, but these are the only ones that they're interested in. So they form their walk based upon that, and depending on the subjective significance of each of these identities, it will weight the random walk of this walker to maybe get into this future cone or that future cone or whatever. But we find that in similar clusters, we have areas of similar convergence. And this is kind of a basic diagram of how the Tangle operates at a wide scale, where you don't see anything to the left of this, to the right of that, and maybe there's some spots in the middle that you ignore that maybe some of these reference. But what's important to you is these are increasing confidence of consensus convergence, and these are increasing probabilities of future convergence. So we make our walk, and the goal is to get somewhere close to this area where we see that there's a lot of overlap. And that's what our walker aims to do. Once it gets past these, it begins to do walks based upon just the weight of the transactions, or some other mechanism could be devised. But since it doesn't have yet a marker on it, and it stores the cones of the cluster but not other parts, this is going to be most primarily weighted into the future cones of these clusters, and that's what keeps these both together and allows them to stitch sideways without losing consensus in a moving consensus between many clusters. So what is the definition of a cluster? It is a subjective definition to the individual operating node in its perspective. So there are as many clusters as there are nodes, but they overlap. This overlapping is expected to make it much more difficult to cheat the system. And when we're in the context of moving funds cross cluster, we essentially just follow the clusters here, and we apply a fuzzy logic to funds which have only a little acceptance in our cluster. Maybe only this one accepts it, and maybe we don't accept that eventually until many of these accept it. Or rather, if it comes through here and then this one wants to pay it to us, then we would do something essentially in my last video, a conditional acceptance, where we could use the funds and accept them based upon the acceptance of the use of future people, our future economic actors that we're interested in, and their how those end up in the past cones of future markers. I hope that wasn't too much word salad. So we request the cluster in the future and past cones. So anything else we do not request. And the fact that we're requesting in this fashion means that these requests and that these take precedence. We do propagate always, but our propagations have limited stack sizes for their queues, and we pop off the stack dependent on a number of factors. If they fill up with these other ones, we pop off the bottom, and if they if they don't have enough proof of work when we're in saturation. There's got to be, or rather, some proof of resource. There's some resource which is necessary past saturation point to minimize the amount of I guess allow for important messages to be able to broadcast far. But that's essentially the idea of how the Tangle can scale past the individual network limit of a individual network limitations of a node in a broader network. And that's that. The other limitations are, of course, how fast a node can compute the transactions that it receives. But there's the historical expectation has been that networking grows slower than computational capacity. So unless there's leaps and bounds in the bandwidth, then eventually the computation becomes the bandwidth limiter on this. How fast you can compute what you have. And I believe that's largely dominated by the hash function. And I mean, these are Merkle trees that are built upon the hash function fundamentally. Well, I'll erase this off camera. That's that. Feel free to leave questions, or I think these videos can have comments, so leave those and I could answer those, or feel free to reach out to me on Discord. I don't know what my handle is, but Paul Douglas or something like that.